Hey everyone, my name is Arpit and I'm a second year PhD student at Georgia Tech. Today I will talk about DIY, helping people assess the correctness of natural language to SQL systems. This is joint work with awesome humans from Microsoft Research, Adam Fourney, Bongshin Lee, and Gonzalo Ramos. A natural language to SQL or NL to SQL system, given a database, takes in a natural language question as input, translates it into a SQL query, and executes this SQL query to compute the answer. Now, consider a car expert asking questions about cars to one such NL to SQL system. They ask, which car models are produced since 1980? Based on prior knowledge, they think that the computed answer is correct, but wonder if the temporal filter was applied correctly. Some systems also present the generated SQL query, but the user does not know SQL. They somewhat interpret the filter-like statement, but have no idea what the other statements mean. Many systems output similar responses, presenting challenges for users who may be familiar with the domain, but have little or no experience with SQL. In this work, we study how such human AI NL to SQL scenarios can be improved by helping users to inspect system responses for correctness, isolate errors if any, and fix those errors if possible. Let us now see how a DIY integrated conversation UI can help the user in understanding the system's response to the earlier question. On seeing certain important keywords highlighted in orange, specifically since and 1980, the user's concern of a missing temporal filter is partially resolved, but they are still unsure if the operator that is greater than or equal to is correct. To debug this, they open DIY's interactive sandbox where they see the same annotated question augmented with the corresponding mappings in the generated SQL query. For example, the keyword models is mapped to the model list table and model column. The user discovers that since is wrongly mapped to greater than and fixes it to greater than or equal to. DIY has also created a sample testing database of relevant tables, columns, and data values by smartly sampling from the production database. DIY then multimodally explains the execution of this generated SQL query on the sample database. The user inspects these explanations, including the final answer, and is now confident that the system's strategy is indeed correct. To be absolutely sure, the user can modify the sample database and see the updated answer in real time. For example, they modify a value from 1981 to 1979 to verify the inequality. DIY updates subsequent steps in real time, and as expected, the corresponding car model is dropped from the final answer. Note that modifying the sample database does not modify the production data. Now completely satisfied, the user executes the correct strategy on the production database to compute an updated answer. A quick verification by comparing the two responses confirms that the updated answer is indeed correct. In this way, DIY helped the car expert with limited database experience debug and fix an NL to SQL scenario. DIY can also benefit information workers who cannot write complex database queries, and computer scientists who took a database class in school but are now a little rusty. There has been much work in the HCI and database communities to explain and correct system responses using natural language and visualizations. There has also been a recent surge in deep learning-based frameworks that are pushing the boundaries of NL to SQL translation. In this work, we leverage RATSQL, a state-of-the-art framework, as our NL to SQL backend. As described earlier, this is a standard NL to SQL pipeline. DIY creates a small but relevant sample of the production database, splits the generated SQL query into smaller sequels, and explains their execution on the sample database using natural language and tabular visualizations. DIY also presents the mappings between the input question and the generated SQL for modifications. Now, let us understand how the sample database is created. DIY first identifies the table names referenced in the SQL from and join clauses. Then, it identifies the referenced column names and together creates the schema. Next, DIY looks for specific SQL clauses such as join and where and identifies smart constraints that will help determine what data values to insert. For example, if there is a join condition, the values in the sample database are chosen such that the result set after execution is non-empty. If there is a where clause, DIY creates one constraint that satisfies the condition and a reverse constraint that does not satisfy the condition to explain using a before-after scenario. DIY tries to satisfy these constraints and picks 5 data records for each table. Now, sometimes the DIY-generated sample database may not always be effective. For example, show me car manufacturers on Mars does not have a non-empty result set yet. In such cases, DIY leverages a human-in-the-loop approach, where users can directly modify the data in the sample database to either create a more appropriate data sample or debug the system strategy using different what-if scenarios. To facilitate these tasks, the sample database is comprised of interactive tabular widgets that support different operations such as adding, updating, and deleting records. After the sample database, let us now understand how DIY explains the generated SQL on it. First, DIY explains the from and join clauses by curating a select star statement without the where clause. This SQL is executed on the sample database and the result is presented with a natural language explanation of how the tables are joined and the result set post-execution. This is step 1. Step 2. The where clause is explained by striking out the rows that don't match the where condition. Step 3. The select clause is explained by choosing just the columns mentioned in the original SQL query. And finally, step 4. The distinct clause is explained by choosing only the unique records. We believe if users trust the system's strategy and answer on the sample database, they may trust the actual answer on the production database more. To understand if DIY really helps users to inspect for, isolate, and fix errors in NL to SQL scenarios, we conducted an exploratory user study with 12 users from Microsoft. Each session lasted 90 minutes, wherein participants were presented with 8 predefined tasks of different complexities and correctness. Users found DIY to be useful in building more transparent systems that explain how the system works, while also allowing the user to take control when needed. Some participants were confused when the answers on the production and sample database did not match, while some had data integrity and ethical concerns with manipulating the data, even if it is in a sample database. We observed different debugging rationales of our users. For example, some used DIY to double-check the system's answer, while some used it because they didn't have enough domain expertise to trust the answer, or because they detected errors that required fixing, or just because the capability existed. We also observed our users employ different debugging strategies. For example, some users tested boundary conditions by editing specific values, while some users deleted records to keep absolutely relevant data. Some users, not wanting to make specific changes, used the shuffle feature to randomize all values in that column. And some users who did not want to modify existing data added a new test record. Interestingly, some users modified already correct mappings, for example, changing average to maximum to simulate a what-if scenario. This direct manipulation technique is actually an opportunity for the future to facilitate data exploration. That is, answer a new but structurally similar question without having to paraphrase. Some users mapped the keyword since to greater than, while some mapped it to greater than or equal to. DIY can be utilized to resolve such ambiguities between conversational and formal language. Finally, DIY can also be integrated with online tools such as SQL Try It Editor to learn and teach SQL with a natural language interface. For more information, please read our paper and reach out to us. Thank you.